Hey, very good, Ken. I'm going to be going over the quiz questions from last week. I wanted to make sure that you knew how to do these questions prior to taking the test on thermochemistry on Friday. Just so you know, there will be a test on Friday if you haven't been keeping up. A test on Friday over Q equals MC delta T stuff, phase changes stuff, enthalpy, heat of vaporization, heat of fusion, stuff like that. And then also how a solution's boiling point and freezing point changes based on the addition of a salt. And there's a video posted, a guy that I found who did a really good job explaining it. I posted that video for you to watch and to understand what at the molecular level what is happening there. But I want to go through the quiz to help you guys understand what the answers to the questions were. Let's go ahead and go through the first one here. So it says a 50-gram bulb of silver is heated in an oven from 20 degrees Celsius to 1500 degrees Celsius. How much heat is gained by the silver bulb if the specific heat of silver is 0.233 joules per gram Celsius? All right, there's my document camera. Let's go ahead and zoom in a bit. Okay. So the question is, if you've got a bulb of silver, a ball of silver, and it's heated up from 20 to 1500 degrees Celsius, and it weighs 50 grams, how much energy is it taking in doing that process? So to answer that question, you'd use Q equals MC delta T. And really just a plug and chug kind of question here. You plug in the mass of 50 grams, the specific heat, 0.233 joules per gram Celsius, and then the change in temperature, which would be 1480 degrees Celsius. So we plug that into our calculator. So 50 times 0.233 times 1480, and we get 17,242 joules. 17,242 joules. So if your answer was close to that, that was the correct answer. Now, B, I actually took that out of the test simply because it's impossible to draw a diagram. So what's going to be happening here is that the bulb is going to be taken from the water or from the oven and then deposited into some water. So it's going to look kind of like this. Okay, so the water is going to take that heat in from the bulb going in, and we are going to try to calculate the temperature of the water. So it says if you put that bulb into 500 milliliters of water, which is at 10 degrees Celsius, and then once he says what temperature will the water rise to, and then justify your answer with a calculation. Okay. So the thing to keep in mind here is that the amount of energy that the silver has, that's going to be what the water takes in. Now, when the bulb goes into the water, the hot silver goes into the water, that silver is going to release its heat into the water, so it's going to be an exothermic process for the water, or for the bulb, and endothermic for the water, so it's bringing in heat. So what we need to do here is we want to figure out the temperature of the water at the end of the reaction by using Q equals MC delta T. So the water is going to gain 17,242 joules of energy, and that's going to be equal to, we have 500 milliliters of water, so that's 500 grams of water. The specific heat of water is 4.18 joules per gram Celsius, and then we don't know the final temperature, but we know the initial temperature of that water is going to be 10 degrees Celsius. That's what they told us. Okay, so this is again just kind of an algebra problem. Let's go ahead and do that. So 17242 equals 500 times 4.18. Okay, 2090. So I'm going to distribute that 2090 to everything in the parentheses. So 2090 TF minus, and then 2090 times 10, 20900. Okay. Go ahead and do the math here. 2090 TF equals, so 20900 plus 17,4242. So we get 38,142. Divide by 2090, and TF, the final temperature of that water, is going to be 18.25 degrees Celsius. About 18.3 is what I think I put on the answer key. Okay, and that makes sense. Remember that water's temperature does not change very much when you add heat to it. It is going to only very little bit change the temperature of the water. Water is very good at absorbing heat before changing its temperature. Also, I did unfortunately receive some answers which made absolutely no sense. Sometimes people told me the temperature of the water went down. That doesn't make any sense because hot metal going into water would make the temperature go up. That just doesn't make any sense. And then the temperature shouldn't go up to like 500 degrees Celsius. You're not going to vaporize the water by adding in the relatively small piece of metal into the water. All right, let's go on to the next question. Okay. Number 2. A lot of people did not get number 2 correct. A 12.7 gram sample of sulfur S8 is burned within an enclosed container submerged in a large beaker containing water. The beaker contains 2.20 liters of water. During the experiment, the temperature of the water is monitored. From these data, calculate the molar enthalpy of sulfur combusting in kilojoules per mole. And then we are told, okay, I'm told the temperature of the water before the reaction and after the reaction. Okay. Okay. So let me just kind of draw a diagram here. What they're saying is you've got some kind of container. Can you see that? Nope. And you have water in that container. And inside that container, you've got another container which has a reaction taking place. Okay, that reaction is with sulfur, S8. They tell us that there's 2.20 liters of water. And they also tell us, let me look at the question here, they tell us that the mass of the sulfur is 12.7 grams, and the temperature before, so the initial temperature, I'm writing this down on my paper, is 21.08, and the final temperature is 33.8 degrees Celsius. Okay, so I'm writing that down on my paper. Okay, now we can see that. Okay. So the thing here is that the sulfur is reacting inside of this little container, and then the heat that's produced from that reaction is going to either go into the water surrounding it, or water's heat is actually going to go into the reaction. When you look at this right here, the temperature change for the water, you can see that the temperature change is going up. Okay, so that means that the heat from this reaction is going out into the water. So heat is being released into the water, raising the temperature of the water. Now we want to find the molar enthalpy. Remember that enthalpy can be calculated, forgot that little h there, equal to the mcdeltaT of the reaction divided by the number of moles. In this case, it's going to be S8. How many moles of S8 actually reacted? Now remember, we cannot directly calculate mcdeltaT for the reaction itself. However, we know that the reaction's heat is going to be exactly what the water gains. How do I know it's an exothermic reaction? That's actually the next question. I know the reaction is exothermic because the temperature of the water increased. So water gained heat while the reaction lost heat. So heat is being released out of the reaction and into the water. Okay, so I can calculate this though. I can calculate the value of heat gained by the water because I know the specific heat of water, I know the change in the temperature of the water, and I know how much water there is. So let's go ahead and do that. So Q for the water is going to be equal to 2.2 liters. That'd be 2,200 grams because there's 1 gram per milliliter. And 2.2 liters is 2,200 milliliters. The specific heat is 4.18. And the change in the temperature of the water, 33.88 minus 21.08. Okay, so the amount of heat that the water gained is equal to, plug that in, 2200 times 4.18 times, let's do this in parentheses. Oh, can't see, sorry. 33.88 minus 21.08. Okay, so that's a lot of energy there. 117,708.8 joules. Now, I need the answer to be in kilojoules. So I'm going to divide this number by 1,000. I'm just going to do that real quick here. So it's going to be about 118 kilojoules. I'll just round there right now. About 118 kilojoules of energy were absorbed by the water. Now, remember, I got to think about this in terms of the reaction, though. I want to know the molar enthalpy of the reaction. So the reaction's Q is actually going to be negative 118 kilojoules. Okay, because the reaction is exothermic. The heat is being released out of the reaction and going into the water. Okay, and from that, I can go ahead and calculate delta H, and delta H is negative 118 kilojoules divided by, and I don't know the number of moles of sulfur yet because I haven't turned it in grams into moles. So I'm going to take 12.7 grams of sulfur 8, I'm going to divide by the molar mass. And I don't have the molar mass of sulfur right in front of me. And 256.5. Right. 12.7 divided by 256.5, and we get 0.0495. Okay, I'm going to take that number and I'm going to put it down here. 0.0495 moles S8. Okay, and then we do the math. So 118 divided by 0.0495, and we get 2383. So let's do 2384 kilojoules per mole. And it's that right there, negative. It's negative because the reaction is exothermic. And actually, the next question, if we look at the problems, is the reaction exothermic or endothermic? Justify your answer. You can justify this because when you look at the reaction is exothermic because you look at the temperature of the water. The temperature of the water increased, so that means that the heat from the reaction is released into the water, so the temperature of the water increased. A lot of people did not answer this accurately. They said something kind of weird. The main thing I was really trying, it kind of varied between people, but the thing I was really looking for was that you were saying the temperature of the water increased. That's the data that demonstrate that the reaction is exothermic. Some people just said the enthalpy is negative, and while that's true, the enthalpy being negative indicates it's an exothermic reaction. I was looking for information from the experiment that proves that it's an exothermic reaction. That's the thing I was looking for. And so you should have been saying that the temperature of the water increased, and that's how you would get full credit. Number 3. Now, number 3 says, consider the combustion of acetylene, C2H2, in the balanced chemical reaction below. And the enthalpy of reaction is negative 2,512 kilojoules per mole. How much energy will be released if 100 grams of acetylene are reacted with an excess of oxygen gas? Let me go ahead and write down this reaction before we go ahead and do the math for it. We got 100 grams of acetylene, and the enthalpy of the reaction is negative 2512 kilojoules per mole. Okay. So how much energy will be released if 100 grams of acetylene are reacted? Okay, this is a standard stoichiometry problem using the enthalpy of the reaction. So I'm going to take 100 grams of C2H2, and I'm going to multiply this through to moles, and then moles of reaction, and then convert to kilojoules using the enthalpy. So 1 mole, convert that to moles, and the molar mass is roughly 12 plus 2. So 12 plus 12 plus 2 for the carbons and the hydrogens, around 26. Okay. And then use the molar coefficient to convert to moles of reaction. One cycle of this reaction requires 2 moles of C2H2. So 2 moles of C2H2 to 1 mole of reaction. And then in 1 mole of the reaction, we release negative 2512 kilojoules. All right, so that's our math there. So 100 divided by 26 divided by, I'll just do this once, divided by 2, and then times negative 2512. So negative 4830, about 4831-ish kilojoules of energy are released. That's the answer. Let's do the next one. The next question is very similar. We're looking at this reaction right here. So it says when heated, calcium carbonate decomposes to form calcium oxide and carbon dioxide according to the reaction equation below. So I'll go ahead and write that down real quick here. Just give me a second. Calcium carbonate makes calcium oxide and CO2. Okay. They tell us that the enthalpy of the reaction is 178.4 kilojoules per mole. And then they're gonna ultimately ask us about 35 joules of energy. Okay, write that down. So the first question is the reaction exothermic or endothermic? Justify our answer. The reaction is endothermic. How do I know it's endothermic? Because the enthalpy of the reaction is a positive number. If it's a positive number, that means it's endothermic. Done deal. That's all. Last question, how many grams of CaCO3 would decompose if 35 joules of energy were used in the reaction? So essentially, if 35 joules of energy are produced or whatever happens with this reaction, how many grams of the CaCO3 will have been actually used to do that? So let's do that reaction. This is kind of just working backwards. Okay. So here's our reaction equation. I want to figure out if I make 35 joules of energy, how much of this is going to be used. So I'm going to take my 35 joules of energy that they said, and then I'm going to convert that from pure energy to moles of reaction. So in 1 mole, well, you know what? The thing is, this is in joules. I'm actually going to try to do this a little differently. So how many joules are in a kilojoule? Because this is in kilojoules. So 1,000 joules to 1 kilojoule. That way that number is in kilojoules. And then 178.4 kilojoules per 1 mole of the reaction. Okay, and how much CaCO3 is used per mole in 1 cycle of this reaction? 1. Why? Because that molar coefficient is 1. So 1 mole of the reaction gives us 1 mole of CaCO3, and 1 mole of CaCO3. The molar mass of calcium carbonate, I did not pick that up before. It's 100.1. Okay, there we go. So this will take us from energy to kilojoules to moles of reaction using the molar enthalpy value. That's important. and then from moles of the reactant, how many moles of calcium carbonate are used, and then 2 grams. Let's go and do that math. 35 divided by 1,000 divided by 178.4, and then times 100.1. And we get this number right here, 0.0196 grams calcium carbonate. All right, now we're done. Okay, so remember, this is still going to be on your test on Friday. Please make sure to watch that video on how the boiling point and the freezing point change in order to what actually is happening at the molecular level. You're not going to be asked any questions regarding math there, but you're going to be asked about what is happening at the atomic level. If you have any questions, let me know. Have a great day.